Hi team, Mr. Rator here, and continuing with proof chapter 1. This is mixed practice question 14. Let's have a quick read of part A. Prove that n squared minus 79n plus 1601 is not prime when n is a positive whole number. Okay, so as we know that this is prime as it is. Okay, we've got a prime number here. All we need to know that the only way we can prove that expression is not prime is to show that the value here is going to be a multiple of 1601. So if we start and write n squared minus 79n, and then if we factorize that, take the n out, and that will be n minus 79. So if we can find a value here, well, we can find several values of here, which is going to be a multiple when I add it onto there. So I'm going to just straightforward just say, let's just say, call the first obvious value. Let's call n equals 1601. Okay, so once I've subbed that into here, obviously this tells me that this will be a multiple of 1601. This will also, this is then times in by that, so the product of these two, once I've signed this is 1601, the product of these two is obviously going to be a product of 1601, and by adding 1601 I'm going to get a further multiple of the whole expression being a multiple of 1601. So if I plug this number in here and then put it through the calculator and say that was 1601 squared minus 79 and is 1601, then I plus 1601. So by doing this straight away, I'm saying this is going to be a counterexample. That's a multiple of 1601, multiple of 1601. This is multiple of 1601. So when I put this into my calculator, work it out. So you all should do this. We will get 1601 squared minus 79 bracket 1601 close bracket and plus 1601. That will give me the number 24323. Now this will be on your calculator display. Now if I got this number and I share it by 1601, it shows an integer value of 1523. So straight away there you've got a counterexample saying other than 1601. Well, this number, when I put n equals 1601 in it, I get the value, brackets, comma there, I'll get the value 2,438,323, which is also a multiple of 1601. So when it says here, prove that this is not a prime number when n is a positive integer, well, when n is the positive integer 1601 or any multiple of 1601, that value, whatever value comes out, will be a multiple of 1601. Therefore, that expression will not be a prime number, will not produce a prime number. So because we have proved that it's not a prime number, we have just proved it's not prime number. Obviously, prime number has only exactly two factors, one in itself. So being multiple of another number is not a prime number. Okay, so that first one is done. Question. Let's have a look at B. prove that n squared minus 1 is never prime when n is a whole number greater than 2. So we're going back to what is a prime number. So prime number is a number that is only a multiple of 1 and itself. If there's any other multiples within that number, i.e. factors, then it can't be a prime number. So straight away, if I say n squared minus 1, this is different in 2 squares, and I call that n plus 1 times by n minus 1, and we're saying any value greater than 2. So when this is greater than 2, we got two numbers times each other. So this is a factor and this is a factor, and both factors are greater than 2. So other than 1, we also have a factor which is n plus 1, and we have a factor which is n minus 1, which is also greater than 2. So it goes here, any n value when n is greater than 2, n plus 1 is obviously greater than 2, and likewise when n is greater than 2, then n minus 1 is a factor which is also is greater than 1. It's got to be a factor when n is a whole number. Okay, so it's got to be greater than 1. So we've got two factors, hence two factors which are greater than 1, which implies the product n squared minus 1, which implies cannot be prime because it has other factors other than 1 in itself. It has another factor which is, well, it has two more factors here other than itself and 1. So it cannot be prime as it has other factors. Cannot be prime as it has other factors other than 1 and itself. QED. This is a similar reason. This expression n squared minus 7n plus 1 cannot be prime when n is a positive whole number because it has other factors other than 1 in itself. Okay, so this number, when I put this expression and get this number out, this will be a factor of 1601 and itself, and therefore cannot be prime. Similar reason. So when we do this and we show this value, this is a counterexample. Which is enough to prove that this expression is not always prime.